Hi, welcome to Module 3, which is on student loans and home buying. We are going to use a calculator quite a bit in this module. I'm going to use the TI-34, as you can see here on the left. That's my favorite type of calculator for these types of problems because it's got that N over D button you can see on the left-hand side here, and if that allows us to enter fractions into the calculator really easily. You can definitely do this without this type of calculator, but it's definitely helpful. I do want to show real quick, if you do have a graphing calculator, I'm not going to use the graphing calculator as I do these problems, but I just want to show you, if in case you do have a graphing calculator, where you can find a fraction button on here. You can just hit the math button, and then it's in this fraction menu, so you can hit the left arrow to get there the fastest, and then enter for number 1, and then you've got the fraction button with the graphing calculator as well. So that's a great option too if you've got a graphing calculator. And then if you don't have either one of these calculators, or a TI-30 would also be a good option, then you're just going to want to make sure to go step by step and write. You're going to need to write a little bit more on your paper to make sure you calculate all these problems step by step and slowly as you put each piece into your calculator. So enough about that. Just wanted to start by saying that. Let's jump in and talk about some loans. So there's 3 types of student loans. There's federal loans, and I'm just looking at this part right here in our notes. There's federal loans, which means the federal government is loaning the student money. There are federal and bank combinations, so a student might get some money from the federal government and some money from a bank. And then there are private loans. And there are some terms down below. So we've got these 4 terms that describe how the loan, the interest is going to work. So if interest is capitalized, then no interest is paid while borrower is in school. So capitalized versus uncapitalized, that just talks about how the student is paying the interest. So actually, let me just jot that down. So these 2 right here, how is the student paying the interest? Okay, so capitalized interest, no interest is paid while borrower is in school. The downside to that, so there's definitely an upside. The student is not needing to pay anything while they're in school, which is nice. But the downside to that is, as the student is in school, interest is accruing. So accrue just means added up. So interest is accruing while the student is in school, and then after they're done with school, that interest is going to be added to the amount that needs to be paid back. So for example, let's say a student takes out a $50,000 loan, and let's say they're in school, and I'm just going to make up a number here just to make it simple. So let's say while they're in school, $3,400 of interest accrues, meaning it adds up as they're in school borrowing this money. Well, then that means that when they're done with school, they would need to pay back $53,400, and that would need to be paid back over, usually a long period of time. So that's one way that how interest could be handled while a student is in school. Uncapitalized interest would be interest when interest only is paid while borrower is in school. So interest only is paid while borrower is in school. So the student is making payments not on the amount borrowed, like not on the $50,000 if you use my example, but only the interest. And the nice thing about that is if the student can pay some of that interest when they're in school, then they're not going to owe as much in the end. And then there are 2 other terms here, subsidized and unsubsidized, that refer to the amount of interest that a student needs to pay, or if they pay it at all. So a subsidized loan is when interest is paid by the government. That's preferred. I'm going to put a little smiley there. We love subsidized loans because students don't have to pay that interest. They're only, having to pay back what they were given. Unsubsidized loans, which are more common, is when interest is paid by student. Okay, so lots of terms there, but let's go back. We'll refer back to those as we go through the problems. So a couple of formulas here. These are directly from your book. This first box is how we're going to calculate interest that accrues while the student is in school. So if a student, and this box here mentions this, interest only accrues on loans that are capitalized, meaning students is not paying anything while they're in school, so it's being added up, and unsubsidized, which means that students are going to have to pay that interest. So capitalized and unsubsidized loans, we're going to have to calculate the interest that accrues while the student is in school, and we'll use these formulas here in the box. And then when we're asked to calculate the monthly payments at a student loan, we're going to use this formula down here. And you can see that's quite the formula. There's lots of parts, so that's why we really rely on that fraction button, the calculator, to help us. And then one note, this exponent here, negative 120, another way you could write this is negative 12 times t. And the reason negative 20 is written there, this is what the book gives us, is because it's really common for students have to pay back a loan in 10 years. So if t is 10, then negative 12 times 10, that's where they get the negative 120. But just know that if t were something else, so let's say t was 15 years, then you would just do negative 12 times 15, and that would be the exponent instead of negative 120. So there are a couple problems in your homework, and there's one that we're going to do next that's got a time that's not 10 years. So we'll talk about that in a minute. So let's just jump ahead. We're going to go through our first example, and this is a really long example. We've got 3 different types of loans here that we're going to look at. So I'm right down here where it says Parker needs to take out a $50,000 student loan 2 years before graduating. Which loan option will result in the lowest overall cost? Assume all payments are deferred for 6 months after graduation and interest is capitalized. So let's just review. So interest is capitalized means that the student is not paying any interest while they're in school. So interest is accruing or adding up while they're in school. And then if payments are deferred for 6 months, that's an additional 6 months beyond when they graduate where interest is still accruing because they're not making payments. So sometimes it's nice as a student to think, oh man, I really like that my payments are deferred because it gives me that time to not make payments. But just keep in mind that if you ever take out a student loan and this happens, that's time that interest is going to be being added up. So you're actually going to have to pay more in the long run by getting that break for 6 months. So if you can afford to make payments, you can ask the loan company to start your payments right away, and that would actually be more beneficial financially for the student. So just thought I'd mention that. So there's 3 different types of loans that we're going to look at, A, B, and C, and we're going to do one at a time. So loan A is a subsidized loan with 6.7% interest for 10 years. So I'm just going to write down our rate here, little r, is going to be 0.067, because if you take 6.7 and you move that decimal 2 spots to the left, you get 0.067. Time is going to be, time is always in years, so t equals 10. Our principal is $50,000, and that'll be the case for all of these loans. And so when we go up to the box, we can use the formulas in the box and then all of these steps to help us get to our answer here. Now with the steps, the first 3 steps, actually the first 4 steps, have to do with the interest. So this is if the loan is unsubsidized. If the loan is subsidized, like in our case in Part A, there is no interest to calculate because while the student is in school, because the government is going to be paying that loan. Or in the interest while the student is in school. So we're gonna step to just using, and actually, you know what, now that I'm looking at this, it's actually going to be through step 5. We're going to jump to just using the monthly payment formula. So Part A is going to be a little bit quicker. So I'm going to write down the formula, and it doesn't hurt as you do these problems to write down the formula each time. You don't have to, but I like doing this. You can write negative 12 times t if you want, just so that you're set up in case the term is not 10. In this case it is though. So now let's go ahead and plug in all of our numbers. So our principal is $50,000. Our rate is 0.067 divided by 12. And then we've got 1 minus 1 plus our rate times negative 12 times 10, since it's a 10-year loan. So if you have if you have a calculator that does not have an N over D button, what I would suggest at this point is to get more paper, and I evaluate the top. Okay, write down the answer without rounding. Evaluate the bottom by doing the inside of the parentheses first, then the exponent, and then doing 1 minus that number, and then the very last step you'll divide the two. So you're really doing everything step by step. In our case, I'm going to use the fraction button here in the calculator, and it's going to make it easier. So I'm going to hit the fraction button, and I'm going to type this in exactly how it looks on my paper. So I've got 50,000 times, and then I'm going to actually enter another fraction, so N over D, and then 0.067, and you have to use your down arrow to get to the bottom, and then 12. And it's a really good idea to do this with me. So if you've got your calculator, hopefully, or if not, pause the video and go grab it so that you can do this as I'm doing it too. So 1 plus, and then we've got N over D. It's nice, it just makes it bigger. It automatically adjusts for us. 0.067. Whoops, it looks like that 7 didn't get there. You really have to be careful with these, because man, if you forget even one digit anywhere, it's going to throw your answer off. So that's where it's really important to just double check your numbers as you're entering them in. And then I'm going to put this, use this exponent key. We call it the caret key. It looks like a little arrow. And then for negative 12, make sure you use the negative sign, which is down here in parentheses, not the subtraction sign. So they're actually different. And you can get an error if you use the subtraction sign. So negative 12 times 10. Okay, and so we've got $572 and then quite a bit of decimals. So at this point, we always want to round to 2 numbers after the decimal place because we're dealing with money. So I'm going to write $572.84. That would be the monthly payment. So this is per month. And then let's just double check, because all these problems are different. Let's look at what we're trying to find here. So it says assume all payments are deferred. Let's find out, okay, which loan option will result in the lowest overall cost. So we actually have to go one more step further here and find the overall cost. So I'm just going to write overall cost, and that's going to be your monthly payment times the number of months. So there are 12 months in a year, and then we're doing this for 10 years. So 572.84 times 12 times 10, and that's $68,740.80. So you can see here, even though this is the best option in terms of this for the student, because the government is paying the interest while they're in school, which is great, but even then you're borrowing 50 grand and you're paying back over 68,000. So you're paying over $18,000 in interest just for the ability to have this money. So I'm not trying to make you feel bad or stress anybody out, but it's good to know. It's good to know that overall cost. Okay, so let's go ahead and we're going to do this subsidized loan. So the subsidized loan, this means that, I'm sorry, not the subsidized loan. We just did that. That's up above here. That must have got moved down. So I'm going to do the unsubsidized loan. Okay, so with the unsubsidized loan, Part B, we've got interest accruing while the student is in school because the government is not paying that loan. So I'm just going to write that out here and just jot that down. So we've got interest. Whoops, my pen looks like it stopped working there. Let me see if I can get this. There we go. Interest accrues and is added to the principal. So let's figure out, the first thing to figure out, if we kind of go up here, step one, actually, and there's really a step before step one, we have to figure out the accrual period, which is how many months the student is not making payments. So let's just jot that down first. So accrual period. So how long is the student in school? So the student is in school for 2 years. So 2 years times 12 months a year. We're finding this in months. So 24 months that the student was in school, and then an additional 6 months after school that they didn't have to make payments. So the accrual period is 30 months. So there were 30 months where interest was accruing and the student was not making payments. So what we're going to have to do, we'll end up adding that, we'll have to calculate that interest. So in step one, find the annual interest, which is the amount borrowed times the interest rate. So I'm just going to write down here $50,000 times 0.064, and then step two, find the daily amount by dividing it by 365.25. There's actually 365.25 days in a year. So when we're calculating interest, the banks want to get all the money they can. So that's why that 0.25 there. So really here, we're finding the daily interest. And this is the formula that's in the first box on the first page. So when we calculate this, and we always want to round, I'll do that over on the left hand side so you can see how the rounding works. So we're going to use the fraction button, and then we've got 50,000. I want to make sure you have the right number of zeros, because that'll definitely make a huge difference if we get that wrong, times 0.064. So our rate, you know what, let me back up because I didn't go over that. Our rate here for the unsubsidized loan, Part B, is 6.4%. So as a decimal, that's 0.064. So that's why I use 0.064 there. And then we're going to divide. So I'm going to go down. If it cooperates, there we go. And 365.25, and then enter. And you can see we get lots of numbers after that decimal point. We're going to round like you would any dollar amount to two numbers after the decimal place, so $8.76, and that's per day. Okay, the next step is we're going to find the monthly interest. So monthly, if we're paying $8.76 a day times 30 days in a month. We use 30 just as, because we have to pick a number, it's going to depend on the month, but just averaged out, we're going to use 30, and you can always use 30 in your problems, equals $262.80. So that's per month. And then we're going to find the total amount of interest accrued. So total interest that accrues is 260, whoops, not 268, 262.80 times the number of months, which we calculated up here. So there's 30 months while the student is in school, and that amounts to $7,884. So that's the total interest that accrues before the student starts making payments. So what we need to do is we need to add that to the principal. So we are going to take that dollar amount and add it to $50,000. So new principal is going to be $50,000 plus $7,884. So I get $57,884. And that is what is going to go into that monthly payment calculator. So before the student even makes payments. So I'm going to write down my student loan monthly payment formula. And so I'm going to take the principal, which is now $57,884, times the rate 0.064 divided by 12, all divided by 1 minus 1 plus 0.064 divided by 12, raised to the negative 12 times the time. In this case, it's 10 years. It said that in the problem, that the student was going to pay it off in 10 years. And then we can go ahead and we can use our calculator to calculate that for us. So we're going to use the N over D button, and I'm going to put 57,884 times 0.064 over 12, so n over d, 0.064, an arrow down, and then 12. And then I'm going to come down below in the fraction below, and I'm going to do 1 minus parenthesis 1 plus n over d button because we have another fraction, 0.064, again, arrow down, 12, and then arrow to the right so that we get out of that fraction, and then we're going to put n parenthesis and use our exponent key. So you can multiply that, it's negative 120, or you could even type in negative 12. Whoops, not negative 122. You can use your arrow if you make a mistake like I did to go back, and then times 10, and then enter. And we get $654, and if we round, 32 cents. So I'm just going to come over here, $654.32. That's my monthly payment. So I just want to, I'm going to use a different color here so we can really highlight the monthly payment. So we've got a monthly payment of $654.32. I just want to show you the difference looking up above, how that differs with the other monthly payment. So from a monthly payment standpoint, you might say, you know, it depends on the person. Maybe that's a lot, maybe not. But what's crazy is we're going to find out in a minute the total overall cost. So it seems like the difference between those two monthly payments isn't that much. But let's go ahead and compute the overall cost of this unsubsidized loan. And I think you'll be pretty surprised how big of a difference it is. So for the overall cost, okay, we're going to take the monthly payment, $654.32, and we're going to multiply it by the number of months. So that's 120 payments. I could do, let me actually write that out so it's more clear, 12 months in a year times 10 years. So 12 times 10, that's how I got the 120. And then if you multiply that all out, so I'm just going to come over here to my calculator, and then we've got 654. So notice I'm using the rounded value here. So 654.32 times 12 months in a year times 10 years, and we end up getting $78,518.40. So that's the big number here. I'm going to use a different color just to compare the two. So that's the total amount that ends up getting paid back by the student. So you can look here, there's a $10,000 difference between that and approximately the unsubsidized, or I'm sorry, the subsidized loan. So you can see there, it makes quite a bit of difference when the government pays the interest while in school. And then remember, if you ever get a loan and the government is not paying your interest, you have, as the student, have the option to pay your own interest while you're at school, and that can help save you some money. So finally, let's go ahead and do the private loan. So interest is also going to accrue on this loan while the student is in school, and it's going to be the same accrual period as before. So we have 30 months. Okay, and then if we look up at the problem, we want to find the rate and the years. So we're looking at part C here, the rate 6%, so rate is going to be 0.06 and time is going to be 17 years. So I'm going to go ahead and just write that down next to the private loan. So we've got rate is 0.06 and then we've got time is 17 years. We need to figure out the amount of interest that accrues but while the student's at school. So we're going to do the same process as before, only instead of 0.064, because 6.4% was the interest on the last loan, now we're going to do 0.06. So we're going to start by finding the daily interest, so $50,000 times 0.06 divided by 365.25. And then I'm going to go ahead and just write down that answer to make this a little bit quicker. So $821 per day. And then we're going to find the monthly rate. So we're going to take that daily rate, $821, and multiply it by 30 days, since there are an average of 30 days in each month. And we get $264.30 per month. So every month that a student is in school, that's how much money is being accruing or accumulating. So the total interest that accrues is going to be $264.30. That's our monthly interest rate times the 30 months. Okay, that's because the student was in school for 2 years and then another 6 months of deferment. We calculated that for the last problem. So we multiply these two and we end up getting $7,389. So notice that's a little bit less than what accrued with the last loan, and that's just because the interest rate here is lower. So the interest rate is only 6% as opposed to 6.4. So now we're going to calculate our new principal, and we're going to take the $50,000 and we're going to add that interest, 7,389, and we get $57,389, and that's going to be our new principal amount. So then let me just scroll up here. We're going to use that formula. So I'm going to write R equals 57,389 times 0.06 over 12 divided by 1 minus 1 plus 0.06 over 12 to the negative 12 times 17th power. So this is where I'm just going to use a highlighter because this is really important here. That exponent is not going to be negative 120 like the book shows you. You've got to adjust because it's a 17-year loan instead of a 10-year loan. So we're going to go ahead and put that in the calculator, and I'm going to do this one just because I think when students get these problems wrong, usually it's a lot of times it has to do with how they're entering things in the calculator because there's so many different steps. So I want to go through, whoops, we're going to go and do, there we go. Okay, so we got 57,389, and then I'm going to hit times N over D, and then we're going to put 0.06, arrow down, 12, arrow down, and then 1 minus, parentheses, 1 plus, N over D, 0.06, arrow down, 12, arrow to the right, end parentheses, and then we're going to use that exponent key, and at the top we're going to type in negative. Remember that negative sign is down here. Don't use the subtraction sign. So negative 12, and then times 17. Okay, and then hit enter. Okay, so that's our monthly payment. So our monthly payment is $449.41 per month. Okay, so that's going to be, I'm going to highlight that in red. So that's definitely less than the last monthly payment. So you might think, oh, that's a better deal. What's tricky about loans, any type of loans, you can find this with car loans or mortgages, the longer you pay something off, the less, the smaller the monthly payment is going to be. So it's deceiving. Like a lot of times, you know, if you go to buy a car, they might try to talk you into paying the car off for a longer period of time because it makes your monthly payment look better. But you've got to be cautious because you actually end up paying a lot over time. So that looks attractive, but let's actually figure out what that total is going to be, like the total that's paid back, because this is the lowest monthly payment. Okay, so let me just get my blue marker here, and then I'm going to take, so the total, I'm going to take 449.41 times 12 months in a year times 17 years. So let me just highlight that too. That 17 shows up again. So you want to make sure to pay close attention when you've got a loan that's not a 10-year loan. It'll look different than the other problems that you do when it's 10 years. So when we multiply that, we get $91,679.64. And so if we compare, that is by far the greatest payoff. So our first loan had a payoff of 68,000 and some change. Our last one 78,000 and some change, and this one 91,000. So it is the lowest monthly payment, but they're paying the most back. So I hope this helps. I know in Connect there's a problem that also asks you to figure out how much one loan is compared to another, and all you would have to do there is just subtract the two numbers. So if I want to know how much more the private loan is compared to the unsubsidized, I would just do $91,679.64 minus $78,518.40, and that would tell me how much more that loan is. So just using subtraction there. Okay, so one problem, but probably one of the longest problems you'll do in this class. So we're going to actually jump into a different subject here. We're going to talk about mortgages, and the reason that mortgages are paired with student loans is because the formula for mortgages, the monthly payment you can see here is really similar. And if we go through the formula, it's actually the exact same as the one that we just used. So let's go ahead and let's jump into this example, and then we can talk about how we'd use this formula. So the Petty's family, or maybe it's Petty's, not sure, Petty's maybe. Petty's family plans to buy a home for $174,900 and has been offered a 30-year mortgage. So I'm just going to jot down, remember T is always in years, so T is 30. Now I'm not going to jump and say that the $174,900 is the principal, because a lot of times with home loans people put down a down payment, so that's probably not going to be the principal. With a rate of 4.5%, so I'm just going to write down rate equals 0.045. I just took that decimal and move it 2 spots to the left. If they make a 20% down payment, what will be the monthly payment? So the first thing that we're going to have to do is we're going to have to figure out how much are they paying as a down payment, so that we can figure out what the principal is. So for the down payment, I'm going to take 20%, which is 0.20, and multiply it by the cost of the home. So this is how we calculate how much down somebody needs to put. So that equates to $34,980. So this would be the out-of-pocket cash that they would have to give to the bank when they obtain their home right away. So they would give the bank $34,980, which means that they're not borrowing as much as the house costs. So to find the new principal, what we're going to do is take $174,900 and we're going to subtract $34,980, subtract that down payment, and we get $139,920. So that's going to be the principal. Now keep in mind, mortgages are all different. Some mortgages don't require people to pay 20%. Sometimes they might allow you to pay as low as like 5% down. The downside to that is that even though you're not forking over as much cash in the beginning, which is attractive, you actually end up having to pay, your loan amount is a lot more, which means you're going to have to pay a lot more in interest also. So just keep that in mind. So now we're going to go ahead and we're going to use this monthly payment formula from above, and we're going to put in $139,920 as our principal, and then our rate is 0.045 divided by 12, 1 minus 1 plus 0.045 divided by 12 to the negative 12 times, in this case it's 30 years, so I'm going to put a 30 there, and I'm going to calculate that and find the monthly payment. So this would be a great place to pause the video and try this on your own. So $139,920 times N over D, 0.045, down arrow, 12, down arrow, 1 minus, we're going to do parentheses, 1 plus N over D, 0.045, and then right arrow, N parentheses, and then we're going to raise it to the negative 12. Make sure you use the negative key next to the decimal and not the subtraction sign, and then times 30. and then enter. And then we are going to round all the answers, even if your homework directions don't state this. You're going to write all of your answers for these to two numbers after the decimal place, just like we would in any type of money situation. So $708.95, and this is how much this person or this family is going to pay per month for their mortgage. So the next example, this is the really the interesting part, is find the total amount of interest that this family pays if they take the loan in the last example. So keep in mind that they're borrowing $139,920, but let's figure out how much they have to actually pay back. So to do this, we're just going to take the monthly payment amount times the number of months. So they're going to pay $708.95 times 12 months a year times 30 years, which is 360 if you multiply those together. We multiply all that, we get $255,222. This is not all interest. This is the total that they paid. So they borrowed $139,920, but they pay back $255,222. So if we want to know the interest, then what we're going to do is we're going to take the total that they pay back, and they're going to minus what they borrow. So they paid back $255,222 minus $139,920, and that amounts to $115,302. Whoops, I said 302, wrote 320, $302. And that is the amount that they are paying the bank just in interest, which is really crazy when you think about it. It's like so many people get mortgages and they make that monthly payment, but they don't think about that big dollar amount that they're paying just to the bank. So suppose that the Petty's family is also offered a 15-year mortgage with the same rate and down payment. Find the difference in monthly payment and the interest paid between the 15 and 30 years. So this is really significant because, as I said before, if the longer you take to pay off a loan, the more money you're going to pay in interest. And so if you can afford to do a shorter term, whether it be a mortgage, car payment, whatever, you're going to save a ton of money. So in this case, our principal is the exact same as it was before. So $139,920, same interest rate. So we're not changing that. The only thing that we're going to change is that 15 years. Before that was 30, now it's 15. So we're changing one number. And since I've done quite a bit of these, I'm just going to write down the answer here. So the answer is $1,070.38 a month. Okay. So just to put that in perspective, so a 15-year mortgage has a monthly payment of $1,070.38 a month. Our 30-year mortgage, which we calculated on the previous page, was $708.95. So the difference in monthly payment, if we subtract those two, is $361.41 a month. So, that's significant, but the question is, one, can this family afford it? Because they might, or not might, they will save a ton of money. So let's figure out the totals for both. So for 15-year total, we're going to take the monthly payment, $1,070.38, times 12 months in a year times 15 years. And if we multiply that all out, we get 1,926,6840. Okay. Let's see. And then if we do the 30-year total, I'm just going to go ahead and find that from the previous page since we already calculated that. I'm just going to scroll up real quick here. So it looks like, and actually, what we could do is we could, let's actually calculate. I'm going to go back for a minute. Instead of doing the 30-year total, let's actually calculate the amount of interest that this person would pay. So if that's the total, I'm going to subtract how much they borrow, so $139,920, and they end up paying $52,748.40, and that's the interest. So the 15-year interest is $52,748. And the interest in the 30-year mortgage, we figured out on the previous page, I'll just go back, is $115,302. So they actually pay over $50,000 more for the house just by spreading it over 30 years as opposed to paying it in 15. So it's a really significant amount. And then if the person that's buying the house, if the house is more expensive than this, then that difference is going to be even greater. And then also keep in mind that some banks will offer loans that are between 15 and 30. So if the 15-year payment is too much, you could ask if they have a 20-year loan, and maybe that might be more reasonable. So just to make sure, it says find that we answered the question. So find the difference in monthly payment. So the monthly payment difference we found, I'll go ahead and circle that in red. So the monthly payment difference was that $361.41. And then it says find the difference in the interest paid. So if we want to find the difference in interest, I'll go ahead and write that out. So we have an exact answer for that. So difference in interest, we're going to write down the 30-year interest we said was $115,302, and then the 15-year interest was $52,748. And so if we and 40 cents, don't want to forget that. And if we subtract those two, we get $62,553.60. So you're paying $62,000 more approximately for this house just by spreading your payments over 30 years. And then also consider that if you're opting for a shorter period, after 15 years, you wouldn't even have a monthly payment. You'd have to pay taxes, but you wouldn't have to pay anything more for your house, which would be amazing because you could put that money elsewhere. Okay, so last problem, we're going to talk about an amortization schedule. I know it's a mouthful. It's sometimes hard for me to say. And when you take out a mortgage, the bank will often give you this amortization schedule. A lot of times they print it off when you leave after buying a house. You have a big stack of paperwork, and part of that paperwork is this amortization schedule. And what it does is it lists out every single month that you have to pay on this loan, and that means it could be a really long document, because if you're having a 30-year mortgage, that's a lot of months. Every single month, how much you're paying to interest and how much you're paying on principal. And what I mean by paying on principal, it means how much of your monthly payment, that check you're writing for your house, how much of that is actually paying down what you owe on the house, and how much of that is actually going directly to the bank just as a gift to the bank, or not a gift, but a payment to the banks, in exchange for them loaning you this money. So there's some steps here that are listed on the side. If you like written steps, I'm just going to go through this example. So it says compute the first 3 months, and that's what you're going to have to do on your homework too. For the Petty's family, if they take the 30-year loan. So recall the mortgage amount is $139,920. So that's your principal. The interest rate is 0.045, and the monthly payment is $708.95. So we've got all those values. So what we're going to do, you're going to have to fill in all of these boxes. And this is one of those problems where, there's a lot of steps. So it's really important to go slow and write your answers neatly so that you don't make any mistakes. So I'm just going to write down month number 1. Okay, we're going to use the formula, simple interest formula, I equals P times R times T. Sometimes it's called the PERT equation. So the first step is we're going to calculate the interest for this first month. So we're going to take, and I'm just going to write down for time, for all of these, time is always going to be 1/12, because it's one month is 1/12 of a year. So remember, T in all of these formulas stands for number of years. So if we're looking for the interest in 1 month, we want to do 1/12, because a month is 1/12 of a year. So the interest that accrues during that first month is going to be the principal, $139,920, times the rate times 1/12. So we're going to repeat this equation over and over and over again, and the only thing that's going to keep changing is the principal. The rate and the time, so 1/12, those are going to stay the same each month. So we calculate that and we get $524.70. That's the amount of interest that you pay, that this family pays that first month. So they write this check for $708.95. $524.70 of that goes directly to the bank for interest. The bank always pays themselves first. So then we're going to do the payment on principal. And the way we do that is we take our monthly payment, $708.95. That will always be the same in every month. Monthly payment minus what you pay for interest. So you take off the interest, and whatever is left over, in this case it's $184.25, that is what is paid toward the principal. So the crazy thing is this, family is making this payment $708.95 for this first month. Only $184.25 of that money is actually going to pay down what they owe on the house. So, and then the balance, you're going to take the principal, so in this case it's $139,920 minus, and actually it might be helpful, I'm just going to not even write a comma here, because sometimes when I write commas I interpret it as a decimal point and then I get the answer wrong. I'm going to take the principal and I'm going to take off $184.25, which, man, does not seem like a lot when you owe this much. That is what the balance of the loan is. So you're going to put this in this last box here, $139,735.75. So you can see you made this big payment, but it really did not take down your balance much at all. So we're gonna go through this process for another 2 months. So in this, you might want to do this next month with me and then try the third one on your own. So we're gonna first find the interest. And we're going to take, in this case, it changes. So our balance changes, and I'm going to use a different color for what changes. So I'll use green. So we're going to use the balance on the loan, $139,735.75. Okay, that changed from, since we paid a little bit of it down the last month, times 0.045 times 1/12. So we multiply that, we get 524.01. And you notice that's a little bit smaller than the last month's interest. So we slowly pay less interest to the bank and a little bit more on principal. So now we're going to find the payment on principal, and we're going to take our monthly payment amount minus that interest amount, 524.01, and we get 184.94. Whoops, not 95. 94, there we go. So 184.94. So that's a little bit, so it's increasing. So it's going up a little bit, and then the interest went down a little bit. And then the last step, the balance of the loan, is $139,735.75 minus $184.94, and we get $139,550.81, and that's going to go in the spot where it says balance of the loan. Okay, that is going to be your new balance for month 3. So I'm going to come down here and I'm going to write down month 3. And then when I calculate the interest, I'm going to get my different color. I'm going to take this dollar amount from that last problem here, $139,550. That was my principal that I calculated in the last step, and that's going to be my new principal. So I'm going to multiply by 0.045 times 1/12. And when I do that, I end up getting $523.32. So, and that's going to go, I'm just going to scroll up a little bit here, that goes in this interest box for month 3. So $523.32. So notice that went down a little bit from that previous number. So the interest is slowly going down and the payment on principal is slowly going up. So let me just scroll down here. We've got one more step for month 3. Okay, so our next step here is we're going to find the payment on principal, and we're going to take our monthly payment that never changes, that's always constant for the life of the loan, and you're going to subtract the payment on principal that we, or the interest, sorry, that we calculated on that last step, and we get 185.63. And that's going to go up here in this box, 185.63. So notice that increased slightly from that last month. So now every month that goes by, we're paying more down on our house and less money directly to the bank. And then last step is we're going to find our new balance on the loan. So the previous month we had a balance of 139,550.81, and now we're going to subtract what we just paid, 185.63, to the loan amount, and we get 139,365.18, and so that's the balance on that third month. So, man, it seems like a lot of work, and it is. These aren't, short problems, but keep in mind that the process is the same each and every time. So it might be a good idea for you to even rewind this video and try this one on your own. There's also some videos on Connect that show the same type of problem being done again if you want to see it worked out with another example. And that is it. So as always, let me know if you have any questions.